Hey folks, Marco here. Just a quick recap. As you recall, in lecture 1, we have learned how to make a blank ComfyUI node render on the screen. We have then learned how inputs and outputs work and how to connect them. Your assignment was basically to play around with different inputs and outputs and make your own pipeline. In lecture 2, we have introduced data input via widgets. We have learned how widget inputs work for many of the familiar data types like model, VAE, ControlNet, and so on. Today, I hope to finish off widget inputs by looking at the remaining widget types, how to handle whole numbers, how to set up seed widget, that is whole number with this additional widget for randomization, how widget for decimal numbers works, text input widgets, and lastly, logical Boolean data widgets. I want to dedicate this lecture to my wife. Not too long ago, I resigned from my full-time academic position, and Mrs. Litch has continued to support me both emotionally and financially as I'm trying to make this YouTube thing work. This lecture would not have been possible without her continued support. One thing you discover when you first start making YouTube videos is how bad the algorithm is. For the first time, I truly understand why YouTubers drone on and on to like and subscribe. I hate myself for saying this, but if you think the content is good and want me to continue doing this, subscribing, liking, and sharing is critical. At the very least, it is a signal to me whether enough people are interested and if I have a chance to build an audience to teach on YouTube for a living, or whether I need to start looking for a, quote, real job, whatever that means. In other news, if you happen to have $1 to spare, Patreon and Ko-fi links are now available. Links are in the description of the video. And that is all the announcements for today. I must say, it is quite surprising how much effort is required to set up these accounts. Did you ever notice how when platforms take your money, creating an account is easy, but when they are supposed to pay you, a lot more is involved? I mean, I get it. They have to check your identity, comply with laws and all that. But come on, do you really think I plan to do money laundering on Patreon of all places? Please, I'm from Australia. That's what casinos are for. Besides, money laundering is covered later in the course. We're civilized here, thank you very much. Now, let me tell you what's not civilized. Integers are primitive data types in Python, as are floats, booleans, and strings. Calling them primitive in this context means they are the most basic data types built into the language. They cannot be broken down into simpler types. Note that this is very much language dependent, so just because strings are primitive in Python, they may not be primitive in other languages, like C, for example. To introduce each type briefly, we use integers to represent whole numbers. If you need a decimal number, you would use float. Logical, true, and false are Boolean data types, and strings are used for text. Now you know why primitive node is called primitive. Less to do with lack of civility and everything to do with how it changes dynamically as you connect it to different primitive inputs. Now let's have a look at how we can implement primitive data types as node widgets. Let us once again begin with the bare skeleton of a node. I will name the class primitive inputs, and for my first widget, I will add integers as input. This is nothing new for us, it's just a key value pair as we have seen in previous lectures. There is one notable difference, however. Tuple now takes two parameters, the string int, but also a nested dictionary, which is currently empty. Before we discuss the dictionary, let's run the code as it currently is and see what happens. Our node now contains a widget and its default value is 0. If you play around with different values, you will notice that 0 is also the lowest value and 2048 is the highest. Each time you click the arrow, integer value increments by 1. All of these parameters can be changed by specifying them inside the aforementioned dictionary. When you leave it empty, the program sets these numbers for you by default, but they can be changed. Let's do this separately. I will create a separate widget and call it bounded range. Let's make it a range of integers from -10 to 10 and set the default value to 3. You run the code and you should get something like this now. If you use widget arrows, you will see the values will change exactly as you would expect it. If you set the parameter step to 2, input will be restricted to even numbers. So I can make third widget, call it even, no pun intended, and when I run my code, interface allows me to cycle through even numbers, in this case from 0 the lowest to 100 the highest. Note that step parameter always uses min as a reference. If we wanted odd numbers, all we need to do is set min to 1. Perhaps the more practical application of this parameter is for image dimensions, since, as you know, image resolutions that are possible with this technology are restricted to multiples of 8, originally 64, you can use this parameter to restrict image width or height to multiples of these numbers. In previous lectures, when discussing inputs via node connections, I have said that key can be anything you want so long as it's unique. Well, that's not quite the case for integer widgets. Label seed, for example, is reserved, and ComfyUI seems to handle it differently. As you can see, our new dictionary entry is currently identical to the first one. The only difference is the string for key, correct? And yet, when you run the code, seed widget has this additional parameter that controls the randomness, which is absent for the first entry. Apart from this, is there anything fundamentally different for seed integers compared to integers in general? Not really. Everything I said for general integer widgets applies here as well. You can set the default value, step, min, and max. In fact, it's not only that you can, but you must do so, otherwise your seed will only go up to 2048. So this raises an interesting question of how high can you go? Well, what is the biggest number? While mathematicians may say infinity and philosophers may ponder whether numbers exist independently of human thought, programmers are practical people. To them, it's whatever your computer's memory can handle. Look, I will tell you that the maximum value for seed needs to be set to this value here. This is, in fact, what the developer did. However, if you don't understand why this is, you should not just blindly copy it just because I said so. That's no better than copy-pasting code you don't understand from Copilot or ChatGPT. In the interest of time, I have moved my explanation to the end of the video. Float input has much of the same parameters as integer, so I'm not going to spend too much time here. You just replace the whole number with decimals, and once you run your code, you will get widget for input of decimal numbers. Next, we discuss widget for text input. These are implemented using string data types. Here we have the simplest string input, and when you run your code, you will get input like this. When it comes to parameters, just like other data types, strings have default value you can set. In fact, by the way, default is one parameter that all primitive widgets have in common. When you run the code, your node will render with a string widget containing default text. This is a small, simple widget suitable for text input that is not too long, a couple of words, lower trigger word perhaps. However, if you need space for more text, you can enable multi-line parameter. This will make text widget render this way. If text input happens to be a prompt, you can enable dynamic prompts parameter as well. And lastly, we discuss Boolean widgets. Here we have a simple implementation. I have named my widget switch and set its default value to logical true. When I run my code, I will indeed get a switch. As for additional parameters, I am aware of only 2 more, which are used to name the position labels of your switch, label on and label off. For example, let's create a new widget, call it alignment, and set the values of label on and label off to good and evil. Once you run your code, instead of the usual true and false labels we had earlier, labels for different switch positions are now good and evil instead. I want to finish off today with a few handy global imports. If you decide to make your own ksampler node, you can use sampler names and scheduler names imports to fetch a list of samplers and schedulers that are available. If you are making an integer widget to be used as image size in pixels, remember how I said that step parameter needs to be 8? If you're wondering, well, what should your max value be, what value for max you should use, you can import and use max resolution global variable for that purpose. Its value is 16,384. Don't ask me why. I honestly could not figure out why developer uses this number in particular. I know that this number is actually 2 to the power 14, but I guess I'm not really sure if there is more to it or if this is just arbitrary and it could have just as easily have been 2 to the power of 13 or 2 to the power of 15. Developers are busy people, so they don't have much time to answer to everyone's questions. Your assignment is to develop a node called DreamLoader, which seeks and loads DreamShaper checkpoint. Why DreamLoader? Because DreamShaper loaders sounds odd. Obviously, feel free to use any checkpoint you want. This is how the node should look like, but you can obviously make it any way you want. You should use what you have learned today to set up text widgets for prompt input. Notice that aspect ratio is not numerical. Instead, you choose between portrait, landscape, or square, which makes, I guess, UI more user-friendly, so you're not manually entering pixels. If you feel like you are up for it, you can try adding integer widget specifying batch size as well. Clip skip is implemented as Boolean widget. It should be switched off by default, but if you toggle it on, it sets the last layer to -2 and modifies the clip internally. And lastly, you are to package model, clip, VAE, and the two conditionings into a basic pipe data structure and make it compatible with impact pack nodes. To make sure that it is compatible, that it all works, you can try running it together with something like this. And that brings us to the end of the class. All that's left is, as just an extra, to address the question of that strange entry we encountered for the maximum value of seed. I have posed the question of the biggest number on a computer, but let's make the question even easier. What is the biggest 3-digit number? That's not a trick question. The answer is obviously 999, but how did you get to that number? In your mind, perhaps you pictured 3 locations for each digit, and then recalling the 10 symbols we have for numbers, the 10 Arabic numerals, you would pick the biggest one and place that symbol in each box. Because we are using 10 symbols, it's called decimal system, and we could mathematically get 999 by writing it this way. Had we evolved from creatures that have 8 fingers, perhaps we would have used octal system. Your answer to the question would then be 777. Mathematically, that is 8 cubed minus 1 when expressed as a decimal number. Computers, as you know, use binary system, so the biggest 3-digit binary number is 111, or 2 cubed minus 1 in decimal system. Oh, by the way, just to distract you with something, did you know that these numbers, the ones that I called Arabic numerals earlier, did you know that they're actually from India? Europeans call them Arabic numerals because they encountered them through Arabic texts. So they are named after the route of transmission rather than the creators. Of course, Islamic scholars further developed the system, but calling them Arabic numerals overlooks the significant contribution of Indian mathematicians who created a system of numeral and the very concept of zero. In fact, in academic circles, they are often referred to as Hindu-Arabic numerals or Indo-Arabic numerals, as it is more accurate and inclusive of their origin and further developments. And just to clarify, Islamic scholars are not to blame for this. They never claimed these symbols were theirs. For example, this guy here, very famous Islamic scholar who introduced and popularized these numerals across the Islamic world, called them in his publication Hindu numerals. It's not like Arabs weren't using their APA properly. So if you're a European like me, this is entirely on us. I mean, it's in the bloody title. What more do you want? But unfortunately, the name is stuck and we call them Arabic numerals to this day. By the way, Al-Khwarizmi is quite famous, particularly for developers, computer scientists. I can guarantee that almost all of them have at least heard of him. This text he wrote, Al-Khwarizmi on the calculation in Hindu numerals, when translated from Arabic to Latin reads Algoritmi de numero indorum. Yep, this dude's last name is the origin of the word algorithm. And if that's not enough, from the title of another one of his books, Kitab al-Jabr wal-Mukabala, word algebra is the origin of the word algebra. So this guy is the father of algebra. I guess moral of the story, while us Europeans may think of medieval period as dark ages, that same period was not so dark elsewhere. Other parts of the world, particularly India and Persia, were thriving centers of scientific and mathematical discoveries, Islamic Golden Age. So, since the biggest three-digit binary number is 111, and given that you likely have a 64-bit CPU and OS, our question, what is the biggest number, becomes the question of what is the biggest 64-digit binary number. And that will be the integer value we will use for max parameter of seed. So what are our options here? Well, you can either enter binary digit 64 times, I would not recommend that, or you can leave it as arithmetic expression, which is also not ideal. Fortunately, there is a third alternative. As you have realized by now, the base of the power represents the number of symbols or numerals. If I take this number, 64, and express it as a product of 4 and 16, I can raise 2 to the power of 4, which gives me 16 to the power of 16. So an alien creature with 16 fingers may express this number using only 16 digits. It would take the largest of the 16 and write it 16 times. Compact and convenient way to express the largest 64-bit binary number. Given that we only have 10 symbols and fingers mostly, we need to come up with 6 more. Symbols, not fingers. Now, you could ask Indians to invent some more Arabic numerals, but given the overwhelming credit they received, you would understandably get 0 symbols and probably 1 finger. So what we do instead is we borrow the first 6 letters of the alphabet. And thus we have hexadecimal system. In this system, F is the largest of the 16. So we take F and we write it 16 times. As mentioned earlier in the lecture, developer of ComfyUI sets the maximum value for seed in such way, and now you understand why. The number is prefixed with 0x, which tells Python to treat it as a hexadecimal number rather than a string of 16 letters. Thank you everyone for listening and hopefully watching, and class dismissed.